Hi there, and welcome to our first video in our C4 and the periodic table topic. Now I'll introduce what we're going to do in this video. Okay, so our first lesson that we're going to be looking at today is all about atomic structure. Okay, now by the end of this video, you should understand our two objectives. The first objective is to understand the development of atomic theory and to know the structure of the atom and isotopes of that atom. The discovery of atoms. The word atoms comes from the Greek word atomos, meaning can't be split down. And this was a general understanding from the Greek times up until this guy, John Dalton, came up with another idea. He came up with an idea in which the particles or atoms were solid orbitals like a billiard ball. Now, he also thought that if you put two atoms together, then you had a compound. Now, this was generally accepted until this guy, J.J. Thomson. Now he came up with the idea that the solid atom had tiny other particles in it that left the atom when you applied electric charge. These were regarded as the first discovery of electrons. Now, after J.J. Thomson and John Dalton came a New Zealand scientist by the name of Ernest Rutherford. Now, he did an experiment where he tested a gold leaf, and what he did is he fired alpha particles at the gold leaf, and he expected that the alpha particles would hit the gold and fire back. And what he actually found was that they passed through. Some of them deflected, and only a very small number actually came back. And this is where he came out with the idea that there was a very small nucleus and the majority of the atom was empty space. Now, after Rutherford, Niels Bohr took on that explanation, and he came up with the idea that with the nucleus in the centre, there was a surrounding area where the electrons were, and he found out that there were different orbitals or different energy levels, and this is the model that we currently accept today. The structure of the atom. Niels Bohr's model is what's currently accepted even today, and this is where we have this model. In the centre of the atom we have a nucleus, and in the nucleus we have protons and we have neutrons. Around the outside of the nucleus we have electrons, and we'll do more about the electrons in another lesson. Now, the properties of the particles within an atom are as follows. The particle, the proton, has a charge of +1 and a mass of 1. The neutron has a charge of 0 and a mass of 1, and the electron has a charge of -1 and a mass of 0.0005, which is almost 0 when you compare it to the masses above. Elements and compounds. A list of elements is known as a periodic table. Now, elements are made up of one type of atom. So here we have a single atom of one particular type of element. elements could also be made up of more than one atom. So here we have two atoms of the same element. So for example, this could be oxygen. Compounds are slightly different. Compounds are made up of one plus another type of atom. So two types of different atoms. Now this could be an example of hydrochloric acid. Now it can actually have more than two. It can be 3, and it can be an infinite number of atoms possible. Atomic number and atomic mass. Now here we have a typical element on the periodic table. So we've got a box that it's normally in, and we have 4 bits of key information. The first part is the name at the bottom, and that is sodium. Above that we have the symbol Na. Now there are 2 numbers, one at the bottom, one at the top. Now for different periodic tables that you can see printed on the internet or where you find them all over the place, these numbers can change in their position. But you need to remember the low one is what we call the atomic number. And the high one is the atomic mass. Now the atomic number is equal to the number of protons in the element. So sodium here has 11 protons. Now if we remember back, the charge on a proton is a positive number, and the atomic number is equal to the number of electrons as well. So the number of protons and the number of electrons are equal. So our positive charge adds up to plus 11. Our negative charge adds up to minus 11. Therefore the overall charge on an atom is 0, and it's the same for every single atom. Now the top number, the atomic mass, is the mass or the number of neutrons plus the number of protons. So when we looked at the masses of the neutrons, they were plus 1. The protons were also plus 1. Now we know we have 11 protons and we have a total mass of 23. So we need to do 23 minus 11 will give us the number of neutrons that we have. So for sodium we have 12 neutrons. Okay, now here we have a nucleus in here. Okay, now we've got rid of the rest of the atom, but we've just got the nucleus. Now we can see from the key that we've got protons and we've got neutrons, protons being red, neutrons being yellow. Now an isotope here, okay, if we break this word down, iso means the same, and this is the same nucleus. Okay, so if we look at the nucleus we've got 1, 2, 3, 4 red protons, which means according to the atomic number, which is 4, that will be beryllium. Okay, now beryllium has 1, 2, 3, 4 protons, 1, 2, 3, 4, 5 neutrons. Okay, so if we have the 4 protons plus 5 neutrons, we have a mass of 9. Okay, now if we were to make an isotope of beryllium, we have 1, 2, 3, 4 protons. Now here, if we put 1, 2, 3, 4. Let's tidy that up a little bit. Now, we've got 4 neutrons and 4 protons. So, if we were to work out what the mass of this would be, we've got 4 protons plus 4 neutrons will equal a mass of 8. Okay. Now, the atomic number for both of these is 4, so it has to be beryllium. But the atomic mass of this is 9 and the atomic mass of this is 8. Okay. Now, what we do is we can take an average of different isotopes to try and work out what the mass of the isotopes will be. Okay, so that's the end of this video. What we've looked at today then is we've looked at these objectives. Okay, we've looked at the development of atomic theory. That's where we looked at the changes in the ideas from John Dalton through J.J. Thomson and Ernest Rutherford with his colleagues Geiger and Marsden. We've then taken Niels Bohr's model, and that's the model that we use today. We then took the understanding of the nucleus that Rutherford found out, and we looked at how the nucleus can change between one isotope and another, and that's where we get the different numbers of neutrons in the nucleus. Okay, so the atom remains the same in the fact that it's got the same number of protons, but the neutrons change. We've looked at the formation of atoms together. One type of atom makes an element, and if it's more than one type, then it will be a compound. And then we've looked at the structure and the format of the periodic table, where we've got the names and the atomic mass and the atomic number along with the symbol. Anyway, next time we'll be looking at electronic structures. Thank you. Bye.